Welcome to this presentation on availability tactics, goals, and definitions, presented by DeepLearn. Availability tactics are critical for maintaining a system's operational integrity. To understand these tactics, we first need to distinguish between failures and faults. A failure occurs when a system does not deliver a service that meets its specifications. In contrast, a fault is a potential cause of failure. The main goal of availability tactics is to implement strategies that enable a system to endure faults without deviating from its service commitments. This involves developing fault tolerance mechanisms that can detect, contain, or recover from faults before they escalate into failures. For instance, in a cloud computing environment, if one server goes down, the system should seamlessly reroute requests to a backup server, ensuring that users experience no interruption in service. How effective are your current strategies in maintaining service compliance during unexpected faults? What best practices can you implement to enhance fault tolerance in your applications? Detection of faults is a foundational pillar of maintaining availability. One of the simplest yet effective methods is the ping-echo technique. This involves sending a request to a system component and awaiting a response. If the component fails to respond, it suggests a potential fault. Another critical technique is the heartbeat mechanism, which entails periodic messages exchanged between components to confirm their operational status. Imagine a monitoring system that sends a heartbeat to each service every few seconds. If a heartbeat is missed, the system can trigger alerts or initiate recovery procedures. Sanity checks also play a vital role. They help verify that a system's operations and outputs remain within predefined limits. Additionally, voting mechanisms can be employed in systems with replicated components to ensure consistency. If one instance provides a different output than others, it raises a flag for further investigation. How can you incorporate these detection techniques into your architecture to enhance your system's responsiveness to faults? What challenges do you foresee in implementing these methods effectively? Once a fault has been detected, the next step is recovery. One of the most effective strategies is active redundancy, where multiple components process the same input simultaneously. This means that if one component fails, others can immediately take over, ensuring continuous service without noticeable disruption. Exception handling is another crucial aspect of recovery. It involves identifying and managing exceptions as they occur, potentially masking faults or providing alternative pathways for execution. Rollback mechanisms allow systems to revert to a known good state, which can be particularly useful in transactional systems where consistency is paramount. Moreover, during a failure, implementing degradation strategies ensures that critical functionalities remain operational, even if non-essential services are temporarily disabled. For example, an online retailer might continue to allow customers to browse products even if the checkout process experiences issues. What recovery strategies are currently in place within your systems? Are they effective enough to ensure minimal impact on user experience during faults? Prevention is always better than cure, and this holds true for software availability as well. Predictive models can be employed to monitor system health and predict potential faults before they manifest. For instance, if a database is nearing capacity, alerts can be generated to prompt an upgrade or cleanup. Designing systems with exception prevention in mind involves using techniques like smart pointers and wrappers to avoid common pitfalls. Resource management is essential. Ensuring that your system has adequate resources to handle peak loads prevents overload scenarios that can result in failures. Additionally, user training plays a pivotal role in fault prevention. Often, human error can lead to faults. Providing training and clear guidelines can help mitigate these risks. How proactive is your approach to fault prevention? Have you considered implementing predictive models to enhance your system's resilience? In summary, availability is a multifaceted attribute that combines reliability with robust recovery mechanisms. The effectiveness of availability tactics, ranging from fault detection to recovery and prevention, determines a system's resilience against faults and its ability to deliver uninterrupted service. To maintain high availability, it's crucial to continuously evaluate and enhance your detection and recovery strategies while also being proactive in preventing potential faults. The journey toward achieving optimal availability is ongoing and requires a commitment to learning and improvement in response to evolving challenges. To leave you with a thought, as technology continues to advance, how will you adapt your strategies to ensure that your systems remain available and reliable in an ever-changing landscape? Thank you for your attention, and I look forward to your questions and insights. Thank you for watching this presentation.